So the given problem is for the circuit shown below, find the value of IB, IC, IE. Base current, collector current and emitter current. Consider VB is equal to 0.68 and beta is equal to 75, RB is equal to 60 ohm and RC is equal to K and RE is equal to what K. So for this diagram, you can apply the mesh analysis for this loop. So I can write 2 is equal to IB. The current flowing through this one is IB, RB plus VB. This is your base and this is your emitter. So this is VBE plus IE, RE. Okay. So they have given the VBE value is equal to 0.68. So 2 minus 0.68 is equal to IB, I don't know. RB value is 60 plus IE value I don't know. Right? RE value is what? K. So this is nothing but 2, 2, 1, 3. 1.32. That is equal to IB into 60 plus what is my IE? IE is equal to IC plus IB. So from the diagram I can write IE current is nothing but IB plus IC. These two current are incoming, right? So further I can simplify this on 1.32 is equal to 1060 into IB. This is 1000. So 1000 plus 60 is 1060 into IB plus 1000 IC. So I need to find the value of IC current. It is what they are asking, right? All the currents they are asking. Okay. I can solve from this equation. I can solve VCC. Now so next from this I can write 1060 IB. IC I can write it as beta IB. Okay. So beta value is 75. Therefore I can write it as 75000 IB. 1.32. So on solving I will get 76060 IB. So from this I can write it as 1.32 divided by 76060. This is your IB value. So I'm solving, I will get 1.32 divided by 76060 is nothing but 17.35 into 10 power minus 6 amps. Okay. So now what is IB? IB is equal to 75, right? 75 into IB. So if you multiply 75, get 1301 microamp. Whereas so if I add IC plus IB, you will get IE, right? So this is 1318.35 is your IE value. So next estimate the value of R such that the VD is 0.9. Consider VTH is equal to 0.4 and mu and CR is equal to 0.4 microampere per volt square. W by L ratio is given and the lambda value, channel length modulation value is equal to 0. So you know that from this 1.8 is equal to IDR plus VD. So 1.8 minus 0.9 is equal to IDR. Okay. So I need to find the value of R, which is nothing but 0.9 divided by ID. So how to find the value of ID? ID formula is, since it is in the saturation region, mu n Cox, and it is given as NPN MOSFET, mu n Cox W by L. W by L is 0.72 divided to 0.18 into VGS minus VT H the whole square divided by 2. They have given mu n Cox is 0.4 milliampere, 10 power minus 3 divided by 2. This is 4, right? 8 into 4, right? This is 4. What is VGS? So here you can see if I consider this is gate and this is source. So VGS is equal to VDS, right? Since the gate is connected. So what is VDS is nothing but VD here. So this is nothing but VD. VD minus VTH is 0.4 the whole square. So on solving, I will get 0.8 into 10 power minus C. VD values they are given as 0.9. 0.9 minus 0.4 the whole square. 0.8 into 0.25 into 10 power minus C. So this is your ID value. You substitute in this formula. 0.9 divided by 0.8 into 0.25 into 10 power 3. So what is 0.9 divided by 8? 9 divided by 8 is 1.125 divided by 0.25 into 10 power 3. So 1125 divided by 0.25 is 4500. It is nothing but 4.5 kilo is your value of R. So the next problem, it is given that mu P is equal to 0.4 mu N. What should be the relative width of the PMOS and NMOS? WP by WN. If the if they are to have equal ID when operated in the saturation region with overdrive voltage of same magnitude. Consider both devices have a equal channel length. So if this is my IDP value is equal to P Cox W by L of P into VGS minus VT whole square divided by 2. This is your IDP, and IDN is equal to mu N Cox W by L of N VGS minus VT the whole square divided by 2. So since they are telling the current of both the transistors same, okay, and VT is equal to VT of P is equal to VT of N, okay. So I can write okay, and the LP is equal to LM. That is also they are given. So I can write mu P Cox W by L of P is equal to mu N Cox W by L of N. Since L is same, I can write like this. Cox also get cancelled out, right? Cox also get cancelled out. So from this they are given mu p is equal to 0.4 of mu n. Wp mu n Wn. So these two get cancelled out. So Wp divided by Wn is equal to 1 divided by 0.4. Okay, which is nothing but 10 divided by 4, right? That is 2.5. So the next problem is for the given GM of one, the first answer. So GM is equal to 20 milli and VTH is equal to 0.4 volt. Calculate the value of RD for the ID current. ID is equal to 1 milliamps. So we know the formula, right? ID formula is beta into VGS minus VT the whole square divided by 2. So if I differentiate D with respect to VGS, I will get 2 beta into VGS minus VT to divide by 2. So this is your GM. Okay. So GM, I can write it as beta into VGS minus VT. Okay. So from this equation, I can rewrite 2ID is equal to beta into VGS minus VT the whole square. So what is 2ID divided by VGS minus VT? That is equal to beta into VGS minus VT. So this I can write as 2ID divided by VGS minus VT. So from this equation, they are given GM value is 20 milli, right? And from this I can write as VGS is equal to VDS, right? So how to find the value of ID? ID is equal, VDD is equal to ID RD plus VDS, right? So I need to find the value of RD. Okay, RD alone. So what is my RD? RD is equal to VDD is 1.8 minus VDS divided by ID. Okay. So ID is equal to 10 milli into VGS minus VT. Okay. So what is ID? ID is 1 milliamps. 1 milliamps is equal to 10 milli into VGS, I don't know. VT value is 0.4. 0.4. So 0.1 plus 0.4 is equal to VGS. So VGS is 0.5, which is nothing but VDS. So 1.8 minus 0.5 divided by ID is 1 milliamps. So this is nothing but 1.3 K. This is your odd type. Next problem is calculate the small signal gain of the given circuit if ID is equal to 2 milliamps, mu and Cox is equal to 100 microampere per volt square, VTH is equal to 0.5. So we know the formula, right? What is small signal gain? Small signal gain is equal to minus EM into RD. So how to find the value of GM? GM is equal to 2ID divided by VGS minus VT. Another formula is that root of 2ID into beta. So how to find 2 into 2 milliamps into beta is mu and Cox W by A. Who's your beta? So root of 4 milli into WL by L is 10 divided by 0.18. Mu and Cox is 100 micro. 100 micro. So this is nothing but 400 into 10 power minus 9 into 10 divided by 0.18, which is 85.55 into 400, which is sitting with root of 0.222 into 10 power minus. Now I'm going to add 0.22 into 10 power minus 4 root of this value, which is nothing but 0.471 into 10 power minus 2. So you're going to substitute in this equation. So minus 0.471 into 10 power minus 2 into 10 power 3, that is minus 4.71. This is your A. So I hope this video is useful for